In this lesson we're going to look at the greatest common factor of a set of numbers. Now we're going to start with the example of listing all factors of 42 and 56. Now this is something you've been asked to do before back in chapter 1. So remember what we do here is we start real easy. Of course 1 is a factor of any number, and we then write the number that goes with it, 42, because of course 1 times 42 is 42. Now because 42 is even, you know 2 goes in, and 42 divided by 2 is 21, so we know 2 times 21 is 42. 3 also goes into 42, and the number that goes with it is 14. 3 times 14 is 42. And then we check 4. 4 does not go into 42, neither does 5. However, 6 does, and we know that 7 goes with it. 6 times 7 is 42. So there's our list of factors of 42. Moving on to 56. Of course 1 and 56 is how we would start this. 2 definitely goes into 56 because it's even, and when you divide 56 by 2 you get 28. 3 does not go into 56 evenly, however 4 does, and it turns out that 4 times 14 is 56. 5 does not go into 56, neither does 6, but 7 does, and 7 times 8 equals 56. So now we have a list of factors for each of these numbers. And so what I'd like to do here is let's circle all numbers that are common to both lists. So we circle a 1 in each list, we've got a 2 in each list. We have a 7 in each list, and finally we have a 14 in each list. And so what we can say, because these are both lists of factors, we can say that 1, 2, 7, and 14 are what we call common factors. They're common factors of the two numbers we're considering, of 42 and 56. Now, as is indicated by the title of our video, we're interested in the greatest one of these common factors. So of course it's easy to see that 14 is the greatest common factor. Of those two numbers. Okay. So what's the formal definition here? Well, the greatest common factor of a set of numbers is the largest number that is a factor of each number in the set. Another way to say the same thing is that it's the largest number that divides into each number in the set. So let's look at a couple examples here. And just like with least common multiple, if the numbers are ever friendly enough that you just know what the greatest common factor is, you can go ahead and feel free to write that down. So you might look at 12 and 18 and recognize, hey, you know what? The biggest number that divides into both 12 and 18 evenly is 6. And if you can recognize that, great. Don't need to see a whole bunch of other work. But like with least common multiple, the bigger the numbers get, the more you're going to want to have a more systematic approach. And so the systematic approach is going to start off just like our systematic approach to least common multiple, and that is we're going to prime factor. So 12 would, break down into 2 times 2 times 3. 18 would break down into 2 times 3 times 3. And then here's what we're going to do with these prime factorizations. We'll write out the little rule down here. The greatest common factor is the product of all factors that are common to each prime factorization. Okay, so what does that mean? Let's see if we can get at this number 6 using this strategy. It's the product of all factors that are common to each prime factorization. So what we're looking for are numbers that show up in both 12 and 18. So we can see right here, 2 shows up in 12 and 2 shows up in 18. Now the moment that I'm able to circle the same factor in both prime factorizations, I get to write that down. So my GCF is going to be a 2, and then notice I have a 3 in both prime factorizations, so I'm going to write down times 3. Now there's another 2 here, but there's no 2 in 18 to match it, and there's another 3 here, but there's no 3 in 12 to match it. So that means our GCF is just 2 times 3, which of course is 6. So this is the more systematic approach. So moving over to the next example, the fact that we're dealing with some bigger numbers here suggests that we should probably just start using this more systematic approach. And so we will take 108 and 28 and we'll prime factor them. Remember, when prime factoring a big number like 108, don't try to be a hero, just find something that goes into 108. And since 108 is even, I think 2 is a logical choice. And 108 divided by 2 is going to give you 54. And that's nice because 54 is a special product. So 54 is 6 times 9, and then you can break down each of those. And so there's our prime factorization of 108. 28 is a little easier. 4 times 7, and 4 breaks down into 2 times 2. So here are GCF. We're looking for numbers that are common to both of the prime factorizations. So I see a 2 in 108, and there's a 2 in 28 that I can circle. So that the fact that I was able to circle 2 in both numbers allows me to write 2 down. And look, I've got another 2 here that has another 2 in 28 that I can circle. So I was able to circle another 2 in both numbers, so I write down another 2. And then we have a bunch of 3s, but there's no 3s in 28 to also circle. We have a 7, but there's no 7s in 108 to circle. So this is it. Our greatest common factor is 2 times 2, which is of course 4. Moving on to this very last one. If I look at 14 and 15 and I use my systematic approach, 14, of course, breaks down into 2 times 7 as a prime factorization. 15 breaks down into 3 times 5. Notice there is nothing I can circle in both numbers, right? No 2s or 7s in 15, no 3s or 5s in 14. So what's our greatest common factor? Well, remember that prime factorization does not ever include a 1 because a 1 is not technically a prime number. But if you go up to the very first example we did, notice that 1 is always going to be a factor of both numbers. And so if you ever prime factor your numbers and there's nothing in the prime factorization they share, the greatest common factor is 1.